everybody, Calvin here, and today I'm going to be covering the CCNA Security Lab Manual version 2, and we're going to be covering Lab 10.1.4.8, which is the configuring the ASAv basic settings and firewall using ASDM. So the topology you see in front of you is the topology shown in the lab manual. However, there is a few changes with interfaces, as I am using GNS3 and different versions of routers. So there's basically 5 separate parts to this topology and 5 separate parts to what we're actually going to be doing today. So part 1 is configuring basic device settings. Part 2 is access the device ASA console and ASDM. Then we'll move on to part 3, which is configure ASA settings and firewall using ASDM startup wizard. Then we're going to move on to part 4, which is configuring the ASA settings from the ASDM configuration menu. Then last but not least, part 5 will configure DMZ, static NAT and ACLs. So the left hand side here, for those that are not following along with the lab manual but would like to know how to operate the basic configurations of the ASA, this left side represents the DMZ. The right side represents the inside network, and the top side represents the outside network. I am using the virtual ASA to run this lab, so a few things might be different. So we're going to go ahead and get started now. So we're going to start by configuring basic device settings. At the moment, nothing is configured on this topology, so I'm going to run through and configure everything from basic settings. So if we look at step 1, it says that we need to cable the network and clear previous device settings. Now that refers to any previous lab that you've had, or if you are running this on physical equipment. We are, and everything is fresh here, so we shouldn't need to worry. I will, however, check the ASAv because I may have stored some configurations on that in previous labs. So we're going to start by configuring the basic settings for the routers and the switches and the devices. In this lab, the DCE interfaces, serial interfaces, need to be configured with a clock rate. However, the routers that I am using do not support clock rates, so I will be skipping that. So I'm going to get started and configure all these device settings. Start with router 1. And let me see if I can just make this a little bit bigger. Okay. Change these settings. There we go, so this should make it a little bit more visible. So I'm just going to show the interfaces as well, because some of my interfaces are slightly different to the topology. So we're going to start by configuring router 1, as I say. This is 10.1.1.1/30 252. No shutdown. Like I say out there, we won't change the clock rate as I say because this router does not support it. And we'll do IP address of 219.165.200.225/29, so it's a 248. Okay, I'll shut down on that. And that's it for that router at the moment, so we'll jump onto router 2 and do the same. Again, I'll make this bigger. Okay. Parents, change 20. There we go. Let's bring that in slightly. Okay, so we'll do the same. Interface serial 20, IP address. Ping it while I'm here. Router 1. Interface has just come up, so we'll just give it a second. Okay. There we go, so that's fine. Serial, let me just do it. And this is the interface now connecting to router 3. And this is 10.222/30. Oops, that's a naughty word. So that's router 2 done for the time being. We'll now move on to router 3. Again, let's change the settings. There we go. And we'll do interface serial 2.1, IP address is 10.221/30. No shut. Interface Ethernet 00. IP address is 172.16.3.1/24. No shut. Okay, we'll jump onto the devices now and we'll configure these, then we'll configure the ASAv. Again, we'll change the settings, appearance. Okay. And IP address for PCA is 192.168.2.3/24. And gateway is 192.168.2.1, which is going to be the ASA's interface. So we'll move on to PCC, then we'll do PCB because that's an actual Windows 7 machine running. So I could download ASDM. Change settings, appearance. And we'll do the same again. So IP address for PCC is 172.16.3.3/24. With the gateway of 172.16.3.1. So we should be able to ping that gateway now. Yep, there we go. So we're getting successful replies there, which is good. Okay, so we'll move on to PCB now, which is a physical Windows 7, well, virtual Windows 7 client running. So we'll just get that up here. We'll change the IP address settings here. Okay. 192.168.1.3/34 subnet. 192.168.1.1 is the gateway. We shall change the DNS settings, and we'll totally take out the secondary one. And that's the IP address for this machine configured, which is where we're going to pull ASDM from. So we'll just go back to our topology, and now we need to configure the ASAv interfaces. So we'll just go to console, and let me just do a show run. Yeah, so it looks like we have a clean ASAv image there, which is good. So we'll go ahead and configure the IP addresses now. So we'll do management 01. Is it management 0? G00 management 00, that's fine. There we go. So we'll do the inside interface address for the ASA. So it's 192.168.1.1. And for those that are actually following the lab manual, you might see that the interfaces work on VLAN, so VLAN 1, 2 and 3. Now I believe this lab manual is referring to the ASA 5505, which as far as I can remember works on VLANs. However, if you are using the ASAv or any newer image, you may not encounter this, so you may not actually need to segregate via VLANs. So that's 255.255.255.0. And our shutdown. We'll go to the first gigabit 02. IP address of, so this is the outside interface, so this will be 192.168 DMZ, sorry. So this will be 2.1. And the last but not least, gigabit 00, IP address of 209.165. 200, 226, 255, 255, 255.0. In fact, that's not the right IP address, so let me change that. And we'll change the subnet mask, which is 248. Okay. Shut. So that should be all the IP addresses configured for all the devices. So we'll move on now to step 3, which is configuring static routes on the routers. So we'll leave the ASAv for now. Let's flick back to router 1. And what we're going to do now is we'll do an IP route. And it's a default route pointing up to router 2's interface. So it'll be 0000 10.1.1.2. We'll do the same with router 3. So everything going to the next hop interface 10.2.2.2. Then for router 2 we need to point 2 different routes. So we'll just get router 2 up. So we need to route everything destined for 209.165.200.224, so the outside interface of the ASA IP address or subnet. We need to route that via 10.1.1.1, which is router 1's next hop interface. Then anything for 172.16.3.0 subnet, we need to route that from router 2 to router 3's 10.2.2.1. Okay, so we'll do an IP route, anything for 209.165.200.204, and we'll do the 255.255.248. It goes to 10.1.1.1. And we'll do another IP route, anything destined for 172.16.3.0, subnet mask /24, and that goes via 10.2.2.1. Okay, so that's the static routes configured. So before we verify any connectivity, we shall move on to step 4, and we'll configure and encrypt passwords on router 1. So just pull router 1 back up. Okay, so we're going to configure a minimum password length. So we'll do that now. So we'll do security passwords. Minimum length is 10 characters. Okay, so that's how you do that. Then now it's going to ask us to configure the enable secret password on both routers with password of Cisco 12345. Okay, so we need to enable the scripting algorithm type. So we'll just go back to router 1, and we can see there that we have script. And then the password Cisco 12345. Oops, secret. There we go. So that's that one done. Now it tells us to do that on both routers. So what I'm going to do is I'm going to go ahead and put it on router 2 and router 3 as well. Okay, so we'll do security passwords, minimum length 10, enable algorithm type, script, secret, Cisco 12345. And we'll do that for router 3 as well. Script. go. So that's that done on all 3 routers. Now it's asking us to create a local admin account. Okay. And we need to use the Type 9 script and privilege level 15. Okay, so we'll start with route 1. We'll do username admin 01. We're going to do privilege 15, and we're going to do secret script, and the password is admin 01 pass. So it's not letting us do that one again with the secret type, so what we're going to do is we'll do, I don't know if it's going to let me do the algorithm type. Yes, it is. So we can do that. Script, secret, and the password is admin 01 pass. So there we go. We'll do that for the other 2 routers. So router 3, we'll do username, and then we'll do privilege 15, algorithm type is script, secret, admin 01 pass. And last but not least, we'll do that for route 2 as well. So we'll do username admin 01, privilege 15, algorithm type script, secret, admin 01 pass. Okay, so we'll flip back to route 1 now. Now that we've done that, we need to configure the console and VTY lines to use the local database for login. For additional security, configure the lines to log out after 5 minutes of inactivity. Issue the login synchronous command to prevent console messages from interrupting command entry. Okay, so we'll do that first on route 1. So we'll do line con 0. And we'll do login synchronous. Then we'll do exec timeout. What did it say? Exec timeout after 5 minutes. Oops, that's wrong. Okay, 5. There we go, that's better. We'll do login local to use the local account. We'll just see if I've got everything there. Yep, login local. Log out after 5 minutes, login synchronous. Okay, so we'll move on to the VTY. We'll do exec timeout 5 minutes, and we'll do login local. Okay, we'll do that for the other 2 routers as well. Router 3. Okay, so now that that's done, we shall move on to the next step, which is enable the HTTP server access on router 1. Use the local database for authentication. No HTTP server access will be used to demonstrate the ASDM tools in part 3. Okay, so we'll do that now. Oops, that doesn't look like it supports. Okay, my image doesn't look like it supports HTTP. There we go, secure. Yep, there we go, that's better. Yep, that's fine. I only forgot the command then. So I've done that on router 1. Now we'll move on to, we'll skip step 5 because step 5 is configuring the PC host IP settings, which we've already done. So we'll move on to step 6 and we will verify connectivity. So let's have a look what it's asking us to do. There will be no connectivity between devices that are connected to the ASA because the ASA is the focal point for the network zones and it is not being configured. However, PCC should be able to ping the router 1 G01 interface. Okay, let's have a look at that. So we'll go to PCC and we'll ping, in our case it's going to be the 209.165.200.225, which is router 1's interface, and as you can see there we get successful replies, so that's good. Okay, Yep, that's fine. So now we're going to move on to part 2, which is access the ASA console from the ASDM. Okay. So if you have any previous configurations on your ASA, you need to clear those configs. If not, then you're fine. I'll just make that a little bit bigger there. Okay, so I'll move on to let me have a look at what it's asking us to do. So we've already done the bypass settings, so what we're going to do is we're going to configure the zones. So in our case, interface management 00 is the inside interface. Okay, so all inside interfaces by default set the security level to 100. It's already specified there as well. So we've already set the IP address for this, so what we'll do is we shall leave that alone now. Okay, just refer back to the lab guide, which is actually, as I can see now, it's using the 5505 ASA for this. As you can see, I'm not using the 5505, however we should still be able to configure this lab. So we'll do a show interface IP brief. So there we go, we can see that's fine. So we've got gigabit 02, which is the DMZ. We have gigabit 00, which is the outside interface, and we also have the management interface. Okay, so I'll move on in the lab now, and we're going to now set the outside interface to security level 0. Okay, just so what we'll do is we'll do interface G02, if call this one outside, and as you can see by default the security level for any outside interface is set to 0. So for those that don't know, or if you're still studying the CCNA security or the ASA, the higher the priority level, when the priority level is set higher than another interface, traffic from the higher level interface can transmit data from the higher priority interface. However, any interface with a lower priority trying to transmit data to a higher priority will be dropped. Okay, so now that we've set the security level, we shall move on to step 4, which is configure the ASDM and verify access to the ASA. So to do that, we need to enable the HTTP server. Enable. Then HTTP server address, IP address is going to be 192.168.1.0. So that's the gateway of our PCB. And then we do inside. Okay. Have I done that? It's because I've got the wrong 192.168.1.0. That's better. And it's inside. There we go. So that means our inside subnet should be able to reach the ASDM now. So now we're going to open a browser on our PCB, and we're going to access the ASA by typing in the interface IP address. Okay, so we'll do that now. So to save some time, I have just got onto the ASDM. I've installed it. You do need Java, so make sure that you install Java. And once you've downloaded ASDM, just run the install wizard. Then you should now have ASDM installed. So what we need to do then is we need to enter the device's IP address. So this is where we're connecting from. So in our case, we're connecting from PCB, and we're connecting to this interface here. So we're going to enter the IP address as we did before for the ASA. Username and password, we haven't created one, so we're just going to go ahead and press OK. It'll continue with the security warning about the certificate, and then it'll begin to load the ASDM GUI. There we go. So once the ASA GUI is loaded, we should be on the main front screen now, and it should look a little something like this. All well, pretty much the versions of ASDM that you might be running should be looking like this anyway. So quick overview, we can see general information about the device here, version we're running, we can see the flash install, we can see the interfaces. So as you can see, we've got the inside and the outside. We haven't done the DMZ yet, and what we're going to do now is move on to the next step in the lab manual, because we've now installed ASDM. So we're going to move on to part 3, which is configuring the basic ASA settings and firewall using the ASDM startup wizard. So it says that we need to it's the first device startup wizard is the first option available and displays by default. Read through the on-screen text describing the startup wizard and then click the launch startup wizard. In our case, we didn't get the startup wizard, so what we need to do is we need to go to this tab here, which is wizards, then click on startup wizard. So there we go, that's how we get startup wizard. So we're going to move on to step 2, which is configuring the host name, domain name, and enable password. Okay, so we'll click next on that because we don't need to change anything. So we're going to, this is where we're going to configure the domain name, etc, etc. So for the ASA host name, we're going to follow the lab manual, which is CCNA S for security, ASA. Our domain name is going to be ccnasecurity.com, and our password is going to be Cisco12345. We never had our old password, so we don't need to worry about that. 12345 Cisco12345. Okay, so we'll click next on that one. Now we need to configure the outside and inside, which is pretty much already done for us. In the lab manual it refers to the VLANs, because it's using the 5505. We're not using the 5505, so as you can see there is no VLAN information here. So I'll just check these settings here. Yep. Outside interface, yep, that's fine. In fact, that's the management. Just go back to our topology. Our outside interface is actually gigabit 00, so we need to make that change. Okay. We'll just leave that. We'll call it outside for now because it's the DMZ. This is our outside. Security level 0. That's fine. And what we can do for the DMZ is we could give it a security level of 50. Okay, and we'll go next on that one. Yeah, that's fine. Just verifying them traffic. Enable traffic between 2 or more interfaces with the same security levels. Enable traffic between 2 or more hosts connected to the same interface. We're not asked to modify that, so we shall leave that. So we'll click next. So it is asking us to that's fine. Yep, so this is slightly different to the lab manual. However, it is asking us to configure DHCP for the inside interface, so we do need to go back. In fact, no, we don't. My mistake. Let me just make sure that they don't want us putting any static roots in. Yeah, not about static roots. Go next. So there we go. DHCP server on the inside interface. Okay, so it's asking us to enter the starting IP address of .31. So 192.168.1.31. And the ending IP address 192.168.1.39. For the DNS server, we're going to enter an IP address of 10, 20, 30, 40, and our domain name is what we created before, .com, CCNA and it says do not check the box to enable auto configuration from interface. So that's it. Let's just have a read of this. So enabling auto configuration causes the DHCP server to automatically configure DNS, WIN server and domain name. The values in the field above take precedence over the auto configured values. Okay, so we'll leave that as it says. We'll move on to NAT, and it's asking us to use port address translation. So we're going to use the IP address on the outside interface to NAT everything. That's cool. We'll click next on that one. And on this step, we need to add SSH access for the ASA for the inside network. Okay, so what we'll do is we'll add SSH for the inside network 192.168.1.0. Add SSH access to the ASA from host 172.63.3 as well from the outside. Ensure that the enable HTTP server for HTTPS ASDM access checkbox is selected. That is selected. So we need to, I'm gonna have to go back because I need to, I'll cancel that in a minute. Let's go back to the outside interface, which is this. Got to put the name there. DHCP server 192.168.1.31 was it? I'll have to go back and just double check that. 1.31 to 1.39. 1.39. CCNA that's fine. There we go. Port address translation, that's not changed. Yep, so now we need to add SSH for the outside interface, and that is 172.63.3, so that is PCC. Okay, 172.16 3.3. 172.16. Why is that not valid? Okay, let me just see if I can edit that. got SSH outside 172.16.3.3. It's asking for the network address, okay, but that's going to allow the whole network. Which we don't want to do, so in fact, my mistake there, we need to do that 3.3. That's fine, so I'll allow that. And we'll go next. We don't need to play about with the auto update stuff. We'll not do that either. So we'll get to the Starter Wizard summary, and this is just verifying the steps that we've taken so far. Okay. So what we're going to do is we're going to click finish on that and let it push those commands. And it's asking us to restart the ASDM and provide the new enable password with no username. Return to the device dashboard and check the interface status window. You should see the inside and outside interfaces with IP address and status. The inside interface should show a number of kilobytes per second. The status window may show the ASDM access as TCP traffic spike. Okay, so there it's asking us to log in again. So Cisco 12345. Yeah, that's fine. And there we go. So we can see the DMZ is down, as it's saying. There we go. So up, up, up. So they're all up now. That's good. So we've got our inside, outside, and DMZ, which is good. So we're going to test access to an external website from PCB. So open a browser on PCB, enter the IP address of the router 1 gigabit 00 interface. So in our case it's the 209.165.200.225 IP address and simulate access to an external website. So we'll do that now. So we'll do 192.168, in fact, sorry, wrong IP address. So it's the 209.165 200.225. Give this a second to load. Okay, so it's not responding. Let's just see if we can ping it. Okay, so we can't ping it. So what we'll do is we'll just check the settings on router 1. Okay, so that's not working. there we go. So now it's working. The reason it wasn't working was because I had not saved the configurations on the ASAv. So now that it's working, we should be able to enter admin01 followed by our password admin01 pass, and that should hopefully now work. Admin01 admin01 pass. Okay, so exit the browser. You should see TCP activity in the ASDM device dashboard traffic status window on the home page. That's not yet because I've not signed in. So what, ping it? Alright, let's have a look and see if we can see why it's asking us to log in all the time. So we can see here from the debugs that the authentication's failing for some reason. So what we're going to do is we're just going to try create another username really quick. We'll call this one WizKid. And we'll do the algorithm type as script again, secret, and we'll just give this one password. Password 12345, and let's see if we can log in with that. Password 12345. And that's not let us in either. So yep, so it's come back again, authentication failed. So what I'm just going to do, because the authentication shouldn't be failing, and for some reason it is. It might be something to do with the actual image that I'm using. Continue, let's just try this one. So we'll use the new one that we created, and password one. So password 12345. So it's still telling us that authentication's failing. We'll try one more time. However, if we do not get through, we shall leave it, but we do know that we can get past the firewall to router 1, which is what we're trying to achieve right now. We'll do admin 01 pass. And there you go, it's not loading, so for some reason it's telling us authentication's failing. I believe it might be something to do with the image that I'm using. So we'll just leave that like that for now. However, the main point is that you can access router 1 and generate some TCP traffic, which is shown then in the status, traffic status here. Okay, but we also know that we can actually reach router 1 because we're getting a login prompt, which is good. So now we're going to move on. And what we're going to do is it's asking us to select the inside interface from the interface drop down list and click TCP from packet type radio button. Okay. That's not on there. Enable syslog as well. Select the inside interface from the interface drop down list. Okay, where is that? Okay. So we're going to click on Tools now. We're going to go to Packet Tracer. Then we need to select interface type as inside. And we need to select TCP, which is already selected. From the source drop down list, select IP address and enter 192.168.1.3, which is our PC that we're on, and we need to enter 209.165.200.225 as the destination IP. The source port 1500. And we are going over HTTP. Okay. Click start to begin the trace, and it says it should be permitted. So this is just having a look at what we've already done. Get to NAT lookup now, passed. And there we can see that everything has been successful and it says the packet is allowed. So now we're going to click clear to reset the entries. So we're going to try another trace and select the outside from the interface drop down list. So outside, leave TCP packet type, from sources drop down list, select IP address, yep, and enter 209.165 200.225 1,500, and the destination IP address 209.165 200.226. So that's the ASA's outside interface, and we're going to select telnet. So telnet, and we're going to begin the trace. Now this packet should be dropped from router 1 trying to telnet to the outside interface of the ASA. Yeah, so there we go. So it says the result, the packet's dropped. Okay, click close. And now we're going to move on to part 4. So in part 4 we're going to configure ASA settings from ASDM configuration menu. So we're going to start with step 1. So we're going to click on configuration. We're then going to, now that we're on device setup, we're going to go to system time. We're going to set the clock. So we're going to select the time zone. So for me, I am London. The date is correct. The time is correct. I'm going to click apply. So now we're going to configure a static default route for the ASA. So on ASDM tools, select ping, and enter the IP address of router 1's interface. So the serial interface, so that'll be 10.1.1.1.1. The ASA does not have a default route to the unknown external network. The ping should fail because the ASA does not have a route to 10.1.1.1. So we're going to do this. We'll go ping. Yeah, so as you can see there, it says it's no route to 10.1.1. So we're going to close that. I'm going to go to configuration, device setup, which we're already in. And we're going to click route in. Then we're going to click on static routes, IPv4 only radio button, and add a new static route. So we're going to click add. And we're going to select the outside, and we're going to networks, we're going to select NA4 with a gateway IP of 209.165.200.225. The NA4 is the default route. So we're going to leave everything else unchecked and we're going to click OK. Then we're going to click apply. Then what we're going to do is we're going to try and do the same thing again. So we'll do another ping, ICMP, and we're going to do 10.1.1.1. We're going to ping, and as we can see now that it's successful, which is good. So we know that that static default route's working. So in the ASDM tools, we're now going to select, we're going to close this, we're going to select trace route, we're going to enter the IP address of the external host, which is PCC, so it'll be 172.16.3.3, and we're going to trace the route. The trace route should succeed and show the hops from the ASAv through router 1, router 2, router 3 to the host on PCC. So yeah, we can see that it's hopped from router 1. We've gone to router 2, router 3, and it's got to its destination there, which is good. So we know that that's working. So now we're going to move on to step 3, which is configuring AAA user authentication using the ASA's local database. So we'll close this. We're going to go to, just bring this up a minute. So we go to click on configuration. Then we're going to go to device management. You are. Click AAA, so nope. Get rid of that. So device management's located down here at the bottom. And once we get to there, we're going to click user AAA. And then we're going to click user accounts. And we're going to add admin01 as the username. The password is admin01 pass. admin01 pass. We're going to do full access, yep, that's fine. We're going to change the privilege level to full 15. And we're going to click OK, and then we're going to apply that. So now on the device management area, we're going to click user AAA, click AAA access, which is this. On the authentication tab, which is what we're on, we need to check the box to require authentication for HTTP, ASDM and SSH connections, and specify the local server group for each connection type. Okay. That's done, that's done. Local. Oops, that's serial SSH. And we're going to click apply. So now that we've done that, we need to now test SSH access to the ASA. So this is step 4 now. So what we're going to do is we're going to open an SSH client. So I should have put it on this device somewhere. So once we have put it open or installed, we can then from PCB SSH to the ASA. And as you can see, it's asking us to log in, so we'll go ahead and log in with the local account that we created, and we'll enter the password as well. So you can see there now that we're in. So if we do enable, we now need to enter Cisco 12345, and we're in. You can see that we're in the ASA there now. And this is all part of step 4 of the lab manual. Now it's asking us to go to PCC and now try to SSH from PCC to the external or the outside interface of the ASA. However, because I'm running PCC on a virtual PC, it will not work because SSH is not supported, only Telnet. What we could do is we can ping the outside interface, and you can see there we've got successful replies, and we can also try and connect on port 22. However, it'll just disconnect us because PCC doesn't support that. So what we're going to do now is we're going to move on to step 5, which is modifying the modular policy framework, which is available on ASAv. Now again, this is in the lab manual. So as you can see there, that's disconnected us. So if you have obviously a setup where you can actually test access from PCC, by all means do so, providing that you've followed the steps correctly, you should be able to access the ASA. So what we're going to do now is we're going to go back to the ASDM, and we're going to go to configuration, firewall, and click service policy rules, which is up here. Okay, and it says the default global inspection policy does not inspect ICMP. To enable hosts on the internal network to ping external hosts and receive replies, ICMP traffic must be inspected on this page. So we're going to select the inspection default one, and we're going to edit that one. I'm going to modify the inspection rules. So under rule actions, we need to select ICMP, and we're not going to change any of the other defaults. I'm going to go ahead, press OK and apply. It's asking us to log in again, so do so with admin. There we go. So from PCB, we're now going to ping the external interface of router 1. So it'll be 10.1.1.1. And as you can see there, that is successful, and it should be. So moving on to part 5, which is configuring the DMZ, static NAT and ACLs. So it says in this part, in part 3, that we configured address translation using port address translation for the inside network. In this part, we need to create a DMZ on the ASA, configure static NAT to the DMZ server, and apply an ACL to control access to the server. So in this step, you'll create a new interface, VLAN 3. In our case, we're not going to do that. Name DMZ, which we've already done, and we're going to assign it to the correct interface with a security level of 70. So we've already done pretty much all of that. However, what we're going to do is we're just going to go to device setup, interfaces, and we're going to edit that. We're going to edit the security level to 70 as it specifies. Okay, I'm going to go ahead and press OK. Create new interface. We've already done all that. Yep. 2.1. Yep, okay. So all that is fine. So we're gonna go ahead and apply that. we can ignore the VLAN, or at least those that are using the ASAv or anything other than the 5505 that works on VLANs. We can ignore the VLAN stuff. So let me just go back onto that. If we go to the advanced tab, just see if any of this applies. No, it doesn't, so we're fine. So we can see already that new interface, DMZ, which is what it's saying that we should see. So that's fine. So now we're going to move on to configuring the DMZ server and static NAT. So it says, to accommodate the addition of DMZ and web server, you will use another address from the ISP range assigned to the /29 of the 209.165.200.224. Route 1 gigabit Ethernet 00 and the ASA outside interface are already using 2 of those addresses. So we will use public address 209.165.200.227 and static NAT to provide address translation so that we can access the DMZ server. So in our case, we're going to be accessing PCA. So we're going to do this using ASDM. And what we're going to do is we're going to go to Firewall. And we're going to go to public servers. And we're going to click add. And our interface is DMZ. And the public IP address 209.165.200.227. Yeah, so public interface, yep, is private interface is the DMZ. Public interface is the outside. That should be the 209.165.226. That's cool. Okay. And we're going to add a private IP address here. We'll call this PCA. In fact, we'll call it DMZ server and description PCA. We'll click OK. And we're going to click OK again. Once we've selected that, so we've selected the private IP address now. So there we go, that's in there. So it says in the add public server dialog, where are we? Public server, so that's a service. Private service, and we're going to allow TCP FTP, and we're going to allow HTTP. Then we're going to allow ICMP echo. So change that to ICMP. Oops, let me click back on that. So ICMP echo. And ICMP echo reply. Okay, so let me just get that back up. ICMP echo doesn't seem to have come up. So ICMP echo reply. I need ICMP echo. There we go, that's better. And we're going to click OK on that. So when we've completed all the information in the add public server, it should look like this. That's correct. So we're going to press OK and we're going to apply that now, like that. So we're going to move on to step 3 and verify the DMZ access rules generated by ASDM. So it says after the creation of the DMZ server object and selection of services, ASDM automatically generates an access rule to permit the appropriate access to the server and applies it to the outside interface in the incoming direction. So we're going to actually have a look at that now by clicking on access rules. So we should have there we go. So that's the rules we've got there, which is correct. So now we're going to test access to the DMZ server from the outside network. So PCC should be able to ping the IP address of the static NAT public server address. So the address we created with .227. So we'll go on to PCC. As you can see there, we can ping that successfully. It says because the ASA inside interface is set to security level 100 and the DMZ is set to 70, you can also access the DMZ server from a host on the inside network, which is what I mentioned already earlier. Okay, that's fine. The DMZ server can't ping PCB on the inside network because the security level is lower, again as I mentioned earlier. So we're going to use ASDM's monitoring to have a look at the activity. So we'll go back to ASDM and we're going to using the monitor screen, which is this one. Okay, and what we're going to do, we're going to go to interfaces, interface graphs. I'm going to select outside, and we're going to select packets, packet counts. There we go. We're going to click add. Then we're going to click on show graphs. We'll just enlarge that a little bit there. And now we're going to, from privilege mode, command prompt on router 2, we're going to simulate internet traffic to the ASA by pinging the DMZ server's public address with a repeat count of 1000. So we'll go to router 2 now. And we'll just log back in. It's timed us out. Going to do ping 209.165.200.227, repeat 1000. I'm going to monitor this now. We'll see what comes through. And then you can see that we're starting to generate some packet counts. On the graph there, which is good. That's fine. So it's now saying from PCB we're going to ping the outgoing interface of router 1, which is a 10.1.1.1. We'll see what happens. So from PCB, okay, we're gonna ping 10.1.1.1 with 100 packets. The response from the PC is relatively slow and it may take a while to show up on the graph as the output packet count. The graph below shows an additional 4,000 packets, so it's just giving us an example of what it should show. So as you can see, we've got our input packet count and our output packet count, which are highlighted in different colors, and that should start generating. Now this is pretty much the end of the lab, so what we'll do is we'll just give it a second to see if we can see any packet counts generated on this graph, and then we shall end the video. Thank you for coming through all this way with me with this quite a long lab of investigating and working on ASDM using the version 2 lab manual of the CCNA security. If you do have any questions, please drop me a comment on the video, or you can message me privately. I do plan on going through the full lab manual and doing all the labs, so that those that just want to follow through and get an idea of what's required can follow through, and also those that may be struggling to get to grips with things can also follow me as I complete all the CCNA security labs. This is in preparation for my CCNA security certification as well, so at the same time I'm learning just as well as some of you guys probably are. So that's it for now. We haven't seen any traffic come through yet, so what I'm going to do is I'm going to end the video, but you kind of understand what's supposed to happen. So again, thank you for watching. Goodbye.